Hello everybody, welcome to A to Z Learning Hub. Today I'll tell you some important things. You know, in set theory there are four types of proofs. One is numerical proof, second one is logical proof, third one is conditional proof, and fourth one is proof from set properties. These types of proofs you find. One is a numerical proof, second one is your logical proof. Logical proofs you can say from definition. Next one is your conditional proof. Fourth one is proof from set properties. First you see, from numerical proof, I have done it many times. For example, suppose A is equal to 1, 2, 3, 4, 5, 6 and B is equal to 5, 6, 7, 8. Then so that question will come like this: A union B minus A intersection B is equal to A minus B union B minus A. You saw it. This is the numerical proof. It will come. You prove, you see. LHS. LHS is A union B minus A intersection B. You see. What is your A union B? These are 1, 2, 3, 4, 5, 6, 7, 8 minus A intersection B. What is your A intersection B? This is your 5, 6 and that is equal to 1, 2, 3, 4, 7, 8. This is your LHS 1, 2, 3, 4, 7, 8. Next come to your RHS. That is your A minus B union B minus A. You see, A minus B 1, 2, 3, 4, 5, 6 minus 5, 6, 7, 8. That is your what? 1, 2, 3, 4. Because from 3, 4 only 5, 6 are out. Union B minus A. B minus A, from B, A is out. That means from B only 5, 6 are out. Then there is your 7, 8. Then what is the value? That is equal to what? 1, 2, 3, 4, 7, 8. So, LHS is equal to RHS. This type of proof. This is called numerical proof. Next come to your logical proof. I have done several types of logical proof. Still that I am doing one problem, logical proof. You see, second one is logical proof. Suppose question will come, A minus B union C is equal to what? A minus B intersection A minus C. Logical. Logical means from definition. Is equal to LHS. Let you do like this: X belongs to A minus B union C. This implies and implied by X belongs to A and X does not belong to B union C. Does not belong to. Implies and implied by X belongs to A and you write X does not belong to A and X does not belong to B. You see, although that is union and that is the negative sign, union is converted into and. Then implies and implied by X belongs to A, you distribute it, X belongs to A and X does not belong to B. X belongs to A and X does not belong to B, and X belongs to A and x does not belong to C. This implies and implied by x belongs to, from definition, x belongs to A and x does not belong to B means A minus B and x belong to A minus C. X belongs to A and x does not belong to C. This implies that A minus. This implies and implied by x belongs to A union A minus B intersection A minus C. So, you get RHS. So, it is clear that you can write A minus B union C is the subset of A minus B intersection A minus C. This is your first equation, and A minus B intersection A minus C is the subset of A minus B union C. So, from 1 and 2 you can write A minus B union C is equal to A minus B intersection A minus C. This is your second type of proof. Next come to your third type of proof. Third type of proof is conditional proof is A union B is equal to U and A intersection B is equal to phi. Then we show B is equal to A dash. How? B is equal to A dash proof means here conditions are given. We have to show B is the subset of A dash and A dash is the subset of B. When two sets are, we have to prove equal, we show B is the subset of A dash and A dash is the subset of B. You see, proof. Let x belongs to B from LHS, you see. This implies that x belongs to U, you can write. X belongs to U. Any set which is belongs to that, then it is x belongs to U. So we can write x belongs to phi dash because you know U dash is equal to phi and phi dash is equal to U. This implies and implied by x belongs to A intersection B complement phi dash. Phi dash is your A, you know A intersection B is equal to your phi. Here A intersection B is equal to phi means, so A intersection B complement is equal to phi dash. Let x belongs to B implies that x belongs to U. This implies that x belongs to phi dash. This because you know U dash is equal, phi dash is equal to U. This implies that x belongs to A intersection B phi dash. This implies that x belongs to A dash union B dash from De Morgan's law. This implies that x belongs to A dash or x belongs to B dash. This implies that x belongs to A dash but or x belongs to B dash because you have taken x belongs to B. So you can write since x belongs to B implies that x does not belong to B dash. So x belongs to A dash. Only this part is not valid. So x belongs to A dash. So we can write x belongs to B means x belongs to A dash. So B is the subset of A dash. This is the first part. Again, let second part. Again I am telling you A union B is equal to U and A intersection B is equal to phi. Then we have to show B is equal to A dash. For this we have to show B is the subset of A dash and A dash is the subset of B. You see, let x belongs to B. This implies that x belongs to u, because A union B is equal to u means x belongs to u. This implies that x belongs to phi dash, you know u dash is equal to phi and phi dash is equal to u. This implies that you know A intersection B is equal to phi means A intersection B complement. This implies that x belongs to A dash union B dash from De Morgan's law. This implies to x belongs to A dash or x belongs to B dash. Since x belongs to B, this implies that x does not belong to B dash, so x belongs to A dash. So x belongs to B means x belongs to A dash, so B is the subset of A dash. Next, let x belongs to A dash. So x belongs to A dash means this implies that x belongs to u, because A dash is the subset of u. This implies that x belongs to A union B from given condition. This implies that x belongs to A or x belongs to B. X belongs to A or x belongs to B. This implies that x belongs to B, because as x belongs to A dash, x cannot belongs to A. So here x belongs to A is not possible. So x belongs to A dash means x belongs to B. So A dash is the subset of B. Second part. From 1 and 2, we can write A dash is equal to B. This is the third type of proof. These are the conditions are given. Using the conditions, you have to prove all this. Next come to your using set properties. Different types of proofs are there, 4 types of proofs. This is your set property. You see, question is using set property. Prove that A union A intersection B is equal to A. Question will come. A union A intersection B. You see LHS, you see, you can write A union A is equal to A intersection A union B. You see, this is your A and this is your B. You see, this is your A union B and this is your A intersection A union B. A intersection A union B, that is equal to A. This is our set property. First part, A union A intersection B is equal to A. You can write, if it at A, you can write A union A, because union is idempotent. Distributive law, A union A intersection A union B. A union A is equal to A, because union is idempotent. Intersection A union B. A intersection A union B. This is your A union B and this is your A, which is common, and this part is your common. We can write A. So A union A intersection B is equal to A. Second one is like similar method. A intersection A union B is equal to A. A intersection A union B is equal to A. You can write that is equal to from LHS A intersection A union A intersection B. A intersection A intersection A is equal to A, because intersection is idempotent. Union A intersection B. First you write A intersection A union A intersection B. A intersection A is your A union A intersection B. You see, A union A intersection B. What is your value of A union A intersection B? This is your A union A intersection B. A union A intersection B is equal to A. This is the proof. here you don't take x. A intersection A union B is equal to A. We have to prove it. You write A intersection A, distributive law. A intersection A union A intersection B. That is your A intersection A is equal to A union A intersection B. A union A intersection B. This is your A union A intersection B is equal to A. This is your RHS. This is the proof using set properties. There are so many types of proofs are there. Now I am doing problems of set algebra or set application. Question you remember, in a survey of 600 students in a school, there are 600 students. It is not necessary that all students will take tea and coffee or both. There are some students who are neither taking tea nor coffee. 150 students were found to taking tea. This is the tea, 150. 225 students are taking coffee and 100 students are taking both tea and coffee, means T intersection C. You see, order of U is equal to 600, order of T is equal to 150, order of C is 225, order of T intersection C is equal to 100. Question will come, how many students are taking neither tea nor coffee, means this part. These students are taking neither tea nor coffee. First we find number of students taking either tea or coffee. So first we find order of T union C, that is equal to order of T plus order of C minus order of T intersection C. That is your 150 plus 225 minus 100, that is your 275. These are taking either tea or coffee. So number of students taking neither tea nor coffee means order of T union C dash is equal to order of U minus order of T union C. So we can write, so order of T union C dash, means these are the number of students who are taking neither tea nor coffee, that is equal to 600 minus 275. 600 minus 275, that is equal to 325. These are the number of students which are taking neither tea nor coffee. You remember this problem, very easy problem. Now I am doing one thing. Suppose there are three sets A, B and C. We find number of elements in exactly two of these sets A, B and C. First you try to understand. Suppose this is your A, this is your B and this is your C. This is your A, B and C. We find the number of elements exactly in two sets A, B and C. Exactly in two sets means this part is not included because these are in three sets. This is one set, this is one set, this part is, these are two sets, this part and this part. We will find this part. We find the number of elements in exactly here. Here the elements are present in only A. Here the elements are present in both A, B and C. But here we find the number of elements exactly in two of the sets. Here elements are present in A and B. Here elements are present only in B and C. These are the elements only in A and C. So, you see, for this section, elements in A and B only is equal to what? Order of A minus B minus order of A intersection B intersection C. This minus this. Elements in B and C only is equal to what? Order of B intersection C minus order of A intersection B intersection C. Elements in A and C only is equal to order of A intersection C minus order of A intersection B intersection C. You see, this is your first equation, this is the first, this is your second, and this is the third. So, number of elements in exactly two of the sets A, B and C is equal to what? Order of A minus A intersection B minus order of A intersection B intersection C plus order of B intersection C minus order of A intersection B intersection C plus order of C intersection A minus order of A intersection B intersection C. That is equal to what? Order of A intersection B plus order of B intersection C plus order of C intersection A minus 3 into order of A intersection B intersection C. This is the answer. So, the number of elements present in exactly two of the sets A, B, C is equal to this part plus this part plus this part. The order of A intersection B plus order of B intersection C plus order of C intersection A minus 3 into order of A intersection B intersection C. Similarly, another interesting question is there. Suppose number of elements in exactly one of the sets A, B and C. You see, this is your A, this is your B and this is your C. You see, number of elements in exactly one of the sets A, B, C means you consider this part exactly in one set, that is A. Again, this part in B and this part in C. That means we can say this part contains exactly in A, this part contains exactly in B and this part contains exactly in C. You see, for A only, number of elements is equal to order of A minus order of A intersection B plus order of A intersection C minus order of A intersection B intersection C, because in this part is repeated, so you can write A intersection B intersection C. This part plus this part minus this part. Similarly, for B, it is order of B minus order of A intersection B plus order of what? B intersection C minus order of A intersection B intersection C. For C, it is your order of C minus order of B intersection C plus order of C intersection A minus order of A intersection B intersection C. Now you add all these. Now by adding number of elements exactly in one set, number of elements exactly in one set is order of A plus order of B plus order of C minus order of A intersection B. Here it is also minus order of A, minus 2 into order of A intersection B minus 2 into order of B intersection C minus 2 into order of B intersection A. You see these are minus minus plus, this is a plus and this is plus 3 into order of A intersection B intersection C. This part, number of elements in exactly one of the sets A, B, C. For you see for first part only, this plus this minus this. This plus this minus this. One you remove. Only just one remove, that means remaining part is intact. So this is the order of A plus order of for A. This is for A, for B and for C, then you add all this. So we can find number of elements in exactly one of the sets A, B, C is your order of A plus order of B plus order of C minus 2 into order of A intersection B minus 2 into order of B intersection C minus 2 into order of C intersection A plus 3 into order of A intersection B intersection C, because minus minus plus, these are minus minus plus and this is minus plus. Another question is there, in a group of students, 100 students know Hindi, 50 students know English and 25 students know both. Each of the students knows either Hindi or English. How many students are there in this group? You see, suppose this is the universal set, this is your Hindi set H and this is your English set. In a group of students, 100 students know Hindi. So order of H is equal to 100 and 50 students know English. 50 students, order of E is equal to 50. 25 know both. Order of H intersection E is equal to what? 25. Each of the students knows either Hindi or English. How many students are there in the group? So we have to find how many students are there in the group. We find order of H union E. So order of H union E is equal to order of H plus order of E minus order of H intersection E. This is your 100 plus 50 minus 25. So this is your 150 minus 25. This is your 125. These are the number of students knows either Hindi or English. So this question is very important. Using set property, prove A minus B minus C is equal to what? A minus B union A intersection C. You write like this, let x be, let you know a minus b minus c, you write a minus b intersection c dash, because a minus b is equal to a intersection b dash. Similarly, a minus b intersection c dash means a intersection b intersection c dash dash, complement of a complement. A intersection, you apply De Morgan's law, b dash union complement of a c. That is your A intersection b dash union c. You apply distributive law, A intersection b dash union A intersection c. That is your A intersection b dash means A minus b union A intersection c. This is your proof. These are the set property. You have to apply set property. For today's class, if you like my teaching, please subscribe, follow, like and share my channel, so that I will be motivated to give you better and better video. For today's, thank you everybody.